Hello everyone. I will start the lecture on the basic part of surface production. And this lecture contains surface production operation related introduction. So surface facility, when we are talking about, that means we have one choke, right? This is choke. From choke it will go to separators, okay? So production, first the production coming from the wellbore, it comes to wellhead. This is wellhead. From wellhead to choke, and then finally the production enters into the separator. So separator may be of different kinds depending upon its design and our requirement. It may be of two-phase separator or three-phase separator or even four-phase separator also. Okay. So what the separator will do? Separator will actually separate the fluid. If this is a two-phase separator, then the well fluid will be separated first in the form of gas. So the gas is now sending through a conductor column. Okay. Actually, this gas contains different kind of corrosive gases, acid gases like CO2, H2S, and even it contain moisture also. So these things has to be removed. Okay. So therefore we have a conductor column. Actually, normal in glass plant we have GSU unit, GDU unit. Okay. First we have GSU unit, then GDU unit. GSU means gas sweetening unit, and GDU means gas dehydration unit. So in GSU unit we are separating CO2 H2S from the gas, from the natural gas, and then we are sending it to the GDU where moisture is separated, and finally the gas is sending to the customer through custody transfer meter. Once the gas will match our desired dew point and gas composition. Okay. So there are some online analyzers in the custody transfer meter where it continuously monitoring the dew point and gas compositions while the sale is going on, right? So this is the case of gas. So we'll discuss this gas separation process in the later videos. Now once gas is separated, we have the liquid portion. Okay. So in the next phase separator, the liquid will be separated. Okay. Like in liquid there are oil and water. So first the oil is coming out from the separator. Actually this separator has a level controller installed within the separator. Actually why it is important, suppose this is defines the oil level controller and this is water level controller. So we have to maintain the specific levels of oil and water within the separator. Otherwise what will happen, water will go into the oil portion, okay, or sometimes oil will go to the gas portions, like that actually. So to monitor the things, so we need this kind of level controller. Okay. So first the oil coming out from the separator. Now this oil before sending it to the storage tank, some treatments is required, like the oil contains some sort of moisture. Okay. So by electrostatic coalizer, we have to fix the water limit. We have to remove the water particles whatever present in the oil, and sometimes some associated water is present in the oil, so we have to treat the oil with demulsifier, okay, before storing it to a storage tank, and from the storage tank it is transferred to the customer via any pipeline or any tanker, right? Now in the second stage of separation, some gases also carry over with the liquid portion, so that gas will also come out in this stage. This is the uh, carried over gas, okay, which is coming out in the next stage of separation. So sometimes this gas has a very low pressure, so we need a compressor to compress the gas and send it to the conductor column, okay. So till now we have separated gas and oil. Now the only thing that remains actually the water, okay. So the water. So this water we can dispose before treating it with de-oiling polyelectrolyte, okay. Dope. This is a very important chemical widely used in this oil industry, because this water contains some kind of some amount of oil, so we cannot dispose this water without treatment, otherwise it will affect the aquifer zone. So you have to treat it with de-oiling polyelectrolytes, which will remove the oil from the water, and finally this water is can be suitably disposed of. So this is the entire process. Now another thing we have to remember, that once the productions coming from the wellbore to wellhead to choke, every time some amount of pressure is lost, like delta P amount of pressure is actually lost. So as we move uh, from choke to separator, from to second stage of separation, so every time some amount of pressure is lost, okay, delta P amount of pressure is lost. So as the pressure is reduced, so what will happen, that the volatile components present in the fluid, that will be eliminated, okay, that will be coming out from the fluid. So therefore in the first stage of separator, we see that we saw that gas is coming out. Again, as the pressure is further reduced, the remaining carried over gas is coming out in the second stage of separation, and after that the oil is coming out from the fluid, okay. So we have to keep remember that every time of separation process in the surface, the pressure is gradually reduced, and therefore, and this is the reason, and therefore actually what is happening, the oil fluid is flowing, right? Because we know that fluid is always flow from high pressure to low pressure, so pressure is reduced all the time, therefore pressure is reduced gradually, therefore what is happening, the oil fluid flows, okay. So this is the basics of surface facilities for the separation of oil and gas, right? Now we are going to the phase diagram of the reservoir fluid. This is a typical phase diagram of reservoir fluid. This point, this red color point, it denotes the critical point of a particular reservoir fluid. The this line, okay, known as the bubble point line or bubble point curve, and the red bold red line, okay, this is known as the dew point line. Already it is mentioned in the diagram. Okay, now question is, what is bubble point? Bubble point is the pressure at which gas evolves out from the oil. That is, the oil has sufficient gas in the solution to fully saturate it. That is the bubble point. Let's say for a particular fluid, we consider this is the bubble point. It is noted as PS, saturation pressure. That means the oil is fully saturated by the gas. So at this pressure, gas will evolve out from the solution. Now one point is mentioned here as Pmax. Okay, one point is mentioned as Pmax. So what it actually signifies? Okay, actually Pmax actually known as Krey-Konderber pressure. Okay, that means what is it? It is the maximum pressure value in the phase diagram indifferent of the shape of this PT diagram. Okay, maximum pressure value. So how we'll get this Pmax value? Actually, we have to draw one tangent, horizontal tangent over this PT diagram, and the point at which it will touch the PT curve, that point is known as, and that pressure of that particular point is known as the Krey-Konderber pressure. And here another thing is that the Tmax, okay, this is known as the Krey-Konderber therm temperature. What does it mean? Actually, this is the maximum pressure, maximum temperature above which liquid cannot exist regardless the pressure. Okay, so beyond this Tmax there will be no liquid. And how we'll get this Tmax? We have to draw one vertical tangent over this curve. So the point where the tangent will touch the curve, corresponding to that point, to the x-axis, defines the Tmax, Krey-Kondertherm temperature. Okay. Now another thing we should mention, that beyond the bubble point line, that is, suppose a point is considered here. So at this point there will be only the liquid is present. So above bubble point curve, only one phase, that is the liquid phase, is present. And suppose if we consider one point below the dew point line, that is this one, only the gas phase will present. So outside the bubble point curve, single phase, that is liquid phase, present. Outside the dew point curve, only single phase, gas phase, is present. Now in between these two curves, that is bubble point and this dew point curve, in between these two phase region will exist, that is oil and gas will coexist. and this region is known as the phase envelope. Okay, and this dew point line or bubble point line, these are called the quality lines or quality curves. So inside two phase region, outside bubble point line, there is one single phase, that is the liquid phase, and outside dew point line, single phase, that is the gas phase present. Okay, now we had already explained why the bubble point is known as the saturation pressure, because at this particular pressure oil is completely saturated with the gas. That means gas will evaporate from the solution in this particular pressure. Now suppose is any point here, suppose in this star, suppose any point is there at this location, suppose this is the point of A, that means it is known as, it is the under saturated condition, like oil is not fully saturated by the gas. Okay, now we should know two terms. Okay, that is, one is live oil, another is dead oil. First let me erase this part. Okay, let me erase these things. Erase these things. Okay, so what is actually the live oil is? Live oil means oil taken directly from the well bore at the same pressure and temperature. So it actually retains all the volatile components. Now what is dead oil? Dead oil, that is without volatile component. Without volatile components. Okay, typically maintained at standard condition, or we can say that stock tank condition. What is it? Stock tank condition means 14.7 psi and 60 degree Fahrenheit. So in brief we can say that live oil is the oil which retains all the volatile components taken directly from the bore at the same pressure and temperature, whereas dead oil, the oil without volatile components, typically maintained at the standard condition or standard stock conditions like 14.7 psi and 60 degree Fahrenheit. Okay, so now again coming to the phase diagram. So when production is coming from the well bore to surface, so there is continuously change in pressure and temperature. So due to change in pressure, so definitely basically pressure is reducing, na? So definitely what will happen? Volatile component will go out. Therefore we should know about the phase diagram for the reservoir fluid. Suppose initially we considered there was one point A. Okay, in the reservoir. So A means that is completely in the liquid phase. A point is completely in the liquid phase because it is above the bubble point line. Now whenever we are taking the production towards to the surface, so pressure is gradually reduced. So let's say we come to point B. So this is the phase envelope region, that means the two-phase region. So here at point B, oil plus gas is present, whereas at point A, only oil is present. And this particular point where it actually cut the bubble point line, this is known as the saturation pressure, what we previously explained. Okay. So from liquid phase we come from liquid phase will reach to two-phase region. Now further the pressure is reduced. Okay, now further we'll reduce the pressure and we come at point C. Okay, so finally it will produce the whole gas because we are tossing the dew point line. So first to check, that is the position in the phase diagram, and then to change the pressure from wellbore to wellhead to separator. So every time we are actually releasing some amount of gas. So whenever we are releasing gas, that means what is happening? We are actually moving from live oil to dead oil situation. Okay. So this is the complete scenario of the PT diagram of a reservoir fluid. So we'll conclude here. In the next video, I will explain what kind of interpretation we can make from a PT diagram. Okay. So thank you.